Welcome to the last presentation for this track, and we will continue for 4 hours. I have no time limit. Göran, it was a little cocktail get-together after this. Yeah, precisely. Yeah. It's been an impressive day today. A lot of good presentations, and many of the presentations was about data. And that is a dear topic for me. So I will talk extensively about data. We also have a lot of good resources. That is good data scientists, data analytics, etc. And I think you've had your topic well covered during today. So I will give you a little flavor about a number of predictive maintenance examples, or predictive methodology type of examples, or similar things to that. And then I will point a little bit in the direction of, do we underestimate the need for data management and data quality? So I will bring that up. And also, how do we deliver trust in our projects, which is very important. How many of you know anything or a little about DNV? Hands up. The norske Veritas, do we have the Lloyd's Register guy in here? No? Oh, good. Yeah, we are buddies. Did you say that Lloyd's has been operating for 238 years?
58.
How much?
58.
58. Yeah, we are a much younger type of organization. We've been around for 154 years. Babies, yeah. But during that time, we have been responsible for taking care of ship data and ship information for 154 years. And one of the earliest ships, I think it was in 1864 or 1865, a Norwegian sailing ship, a military sailing ship. And that is still in operation under DNV class today. So we've been taking care of information for 150 years for our customers. And now we are trying to do that safer, smarter, and greener with safety performance monitoring, automated compliance. And the automated compliance documentation is that we are using data and analytics to stakeholders that replace surveys and audits. So the traditional way of going around to classify a ship is that we provide audits. And an auditor comes to the customer and look at the ship and signs in a form, and the audit is processed and the ship is under class. And now this is going to be done via sensors and machine learning and all the predictive methodologies that we've heard about during today. So we tend to call this, we are unlocking tapped value of data, tracking the challenge of data silos. So DNV goes towards a data-driven decision-making, rules and standards, and the default problem is that data is siloed. And it's valuable to so many, so it means that more and more silos are popping up. If as soon as you have a data environment and you would like to protect that data environment, then you tend to create a new silo for your protective data environment. And that means that the number of silos are just growing tremendously. So if we're going to connect data, integrate data together, can we really trust the data? Can we give the authority to someone to handle the data, manage the data for an enterprise or an operation? Do we trust the custodian of data? So ship owners, asset owners, they come to us and say, we have a problem of sharing data with our contractors and suppliers and partners. Can you take on the role of be the custodian for a ship asset or for an operation or for an enterprise to function? So we are working with precisely that issue and put together a platform with that's based on standards, recommended practices and standards. So we have recommended practices on sensor quality, data management, data quality, cybersecurity. That gives you the trust of industrial data and analytics. We have the data management platform that manages quality ownership and use of big data and other data types. The data management process improvement services, the data curation services, the analytical services. It's in the cloud with Microsoft Azure. And as a basis for everything, a data lake for industrial data. So we are really breaking up the old tradition of handling documentation and really handling data and information now. So our audit services, our classification services, they will change and be data-driven. So, and that is a big issue for DNVGL. So I will give a number of examples of predictive maintenance examples and curation and custodian examples, data provider examples, and for maritime, oil and gas, energy, and business assurance. How many of you are data scientists or data analytics, or work with data analytics? Hands up. How many of you are doing that for ships, maritime? None. For energy? One. Good. For oil and gas? One. Two. Business assurance, and that is certification issues. Okay. Why I'm asking that question is because there's so hard to find people with the combination of domain knowledge for an area and data analytics. And that combined in one single person. So if you have that capability, make contact with me. I would like to talk to you. And especially for these 4 business areas. It's really hard to find that kind of people. So don't be shy. I will not bite you. First example is predictive maintenance on drill ship top drive. And the top drive is in the drill tower. It's a machine up here that actually makes the pipe spin. So that makes the pipe spin. Traditionally, the maintenance task in the offshore industry has been preventive, with the use of sensor data, models, and simulations to derive the technical condition and drive the maintenance scheduling has become to be a new approach. So now it's not only preventive, it's actually predictive. Every one of the examples that I have has a structure with the business problem, the solution, and the value propositions. Now, I will just show this for the first example. So you can imagine that we have a lot of written data and information about these examples. If you would like to have more information, just send me an email. In this example, in one case, we were able to predict failures for the top drive 1 month before it happened. In another case, we were able to predict a failure just 90 minutes before it's happened. So it was during the coffee break they discovered, yeah, etc. It could also be like ship energy generation on performance management. So we have been involved in a research project with an owner of gas carriers, which the objective to contribute towards improving the overall energy efficiency of ships. Through detailed mapping of the energy flow, the identification of energy losses, the continued sensor-based monitoring, investigation of energy-saving technologies, and model-based assessment, this project's aim was the reduction of the ship energy loss. So we are connecting a lot of different sources together. So one data source doesn't have cover the whole issue, the whole problem. Sensor data alone doesn't really cut it. We need more data. And there is a number of sources where we can capture the data.
May I interrupt you? In the previous example,
Yes.
what was the failure?
Failure mode. So were you able to predict the failure mode when you said you were able to predict the failure?
When you said you were able to predict the failure, what was the failure?
It was
the drive or was it the steel or
for the top drive.
yeah? What was the failure that you predicted?
I don't have that here. Yeah, I can give it to you afterwards. Yeah, I don't have the exact notion of what kind of failure it was. In operation performance forecasting based on sensor data and models. Here you combine sensor data with current failure and forecasting models to support planning and execution of maintenance on a continuous basis. Data from gas processing system was profiled and data quality issues identified as basis for the further analytical work. So this is an oil and gas. It's a gas platform. It has a large number of sensor tags. It was one platform. And it was performance forecasting, trying to figure out what is the performance of this platform. Classification modeling on predictive behavior of gas compressors. A gas compressor most of the time is not running, but when you need one, you would like it to start. Sometimes it just doesn't start, and when you have to send the service engineer to fix the problem, this takes time and can potentially result in the customers not receiving any gas. Machine learning methods were used to classify start events. When the model predicted a failure, the start probability was only 75%, and when the model predicted a successful start, the start probability was 95%. So when the model said this is a potential failure, then the start probability was around 75%. And when it predicted a successful start, it was actually in the real life 95%. So that was good. Pipelines, another interesting issue. In order to find the spot where there is corrosion in the pipelines, you really need, you cannot cover the entire length of the pipeline. It could be 100 kilometers long. So you need to find the areas where the predictability of corrosion is highest. Is it underwater or close to water? Is it any type of chemicals in the nature? So you gather together a lot of data, and you use that data to inspect pipelines as a validation set for machine learning. This can scientifically improve the estimation of the presence of corrosion, and we today have a very weak decision support. It's also used predictive analysis in order to measure the data and analyze the data that is captured by a pig. Have you heard about pipelines and pigs? No? It's like a machine that you put into, looks like a little train, but it's rounded, and you put it into the pipeline. And it goes by itself for 15 kilometers or 20 kilometers, and it gathers data all the time of the surrounding pipeline. And when you take it out, then you have a lot of data of potential corrosion. And you use predictive analysis in order to figure out which of the areas are the most probable area for corrosion. Interesting data. The pigs collect a lot of data. Here is a potential customer where we are looking at solar panels and inverters. Energy use for modeling of buildings in the US. And the business issue was in order to administrative monetary incentives for applying energy efficiency measures in dwellings and offices, utilities needed to verify the resulting savings. And under certain constraints, the data-driven approach could achieve more than 40% increase in accuracy while being computed effortlessly. So here they connected into the meters and they collected the data and used predictive maintenance in order, not maintenance, but predictive analysis in order to figure out how much the customers were going to be reimbursed. Another type of customer is in Norway, salmon, fish farms. 3 companies, 29 locations, multiple salmon life cycles. They're looking at the fish, but because the fish have lice. And when they are affected by lice, then the fish is not of sellable quality anymore. So they used the predictive analysis in order to figure out how can we reduce the number of lice so that because that cost the salmon industry billions of Norwegian crowns every year. So the most effective medication methods, sufficient sample size for the lice count, relationship between appetite or temperature and number of lice. So they got proposal of how to actually handle the issue of lice. Data curation role for the health domain. There is a large untapped potential to better diagnosis and treatment through the use of combination of clinical data and genomics. So if we're going to have healthcare diagnostics that we can actually trust and handle, there is a number of barriers for handling that data. Privacy, standardization, quality of diagnosis and treatments, lack of trust to share data sets between institutions. Everything resulted in many fragmented small data sets and lack of trust to use data in diagnosis and treatment by hospitals. So we needed to put up a neutral data management platform for these hospitals. Standardization, we improvement in data quality, we secure data sharing and aggregation across all institutions without compromising the individual patients. So here it was, in order to get any type of predictive methodology analytics to work, we need to put the data together. And that was almost impossible to do in the hospital environment. Predicting the next ports of call and arrival for the world fleet. Maritime companies that operate out of ports and depend on vessel schedules to optimize their operation have limited access to accurate data about ships' arrivals for a sufficient period in advance. And here we could give ships the data they needed in order to predict the arrivals in port. And I think we are offering that to the ship owners for the world fleet. So most ship owners, they have these capabilities. The Veritas Petroleum service fuel testing. Every ship owner, they send in fuel tests about their ships. And that's a database that covers 60% of the whole world fleet. But the data can be used for CO2 capture. It can be used for any compounds that they should not have in the fuel. So the data can be used for many different purposes. And predictive purposes are some, and others are not. I asked the energy department if they had any data analytics use cases, and they made a long list of that. So the sum of the examples, we have descriptive analytics, diagnostic analytics, predictive analytics, prescriptive and cognitive analytics. Different types of analytics, and feel free to check the slide deck. More than 30 pilots with one common success and critical success factor, and that is taking care of the data. Data is in multiple formats in different systems and difficult to integrate the overwhelming number of data streams. Poor data management and use of data, lacking trust in data quality and cybersecurity. This means that it's an asset. It needs to be prospected. It's like oil. It's extracted, it's cleaned, it's refined, it's improved, traded, and recycled. So data is regarded in our industry as an asset. I will just skip through a number of pages here.
Oh, you really have 45 minutes.
Yeah, 40. So we are taking the whole issue of data, and we have made a recommended practice. It's a standard for how to handle data. And you will find the recommended practice under the link, and that addresses data quality assessment, data quality maturity assessment for organization, and data quality risk. So it's 3 areas: data quality assessment, organization maturity assessment, and risk assessment. that will handle how we are going to handle data in our organization. I will skip a few more. So we deliver trust through our data management capabilities. And just to show that we are on the track of really making serious argument around data management, we have now published the annual report for DNV. And we have a chapter that's called Treating Data as an Asset. And that describes the new immaterial asset that we have in the organization. And the next challenge is going to be to make an inventory of critical data assets for the organization and also in value those data assets. So hopefully that will happen during 2018, and we will publish the result in the next annual report in 2019.